How about now? Testing. How about now? Alrighty, cool. We got volume, guys. So a little bit of a change up to the stream here this week. Zach and Parshov are either busy or out of town on vacation, so you are stuck with me. So let's go ahead and get to it. So we keep the same general agenda for the beginning of the stream just about every time, and then we'll throw in a fun topic. So we'll go ahead and go down the line. So for those of you who don't know, I'm Sabian. In Discord, my name is Ambid. Um, one of the community leaders here for oneleif. I specialize in game development and play a hand in just about everything that oneleif does. So something that we like to mention at the beginning of every stream is just how the Discord works for those of you that haven't quite figured it out yet. So once you join oneleif, you'll be stuck in this little start channel all on your own. Until you make a post and introductions, you won't have full access to the Discord. As soon as you make an introduction, we'll upgrade your roles so you can access everything. If you would like channels relative to what you're interested in, for example, Git, AR, VR, audio design, the works, go to interests. All you gotta do is react to a message, and you do that by clicking on one of the emojis down at the bottom, and then they are mapped to the specific channel that you want to have an interest in. Next, we're going to take a look at the direction channel and see what's new. So the direction channel, for those of you unaware, is the channel where we like to post things related to the direction of oneleif as an organization. Also, I don't remember if we mentioned this last time, but oneleif, as of about 3 weeks ago, is a nonprofit. Sorry for not having the stream for the past couple weeks. The holidays have been crazy. But yeah, so oneleif is a nonprofit. What does that mean for you guys? Well, for you guys, you really won't see much of a change. What that allows us to do is take in donations, obviously. But what I'd like to see that allow us to do is to pay for swag, so t-shirts, pens, hats, whatever we decide on, which I believe we have in the direction channel. It's up here somewhere. I think we went over it last time. So look forward to seeing oneleif swag come back. Some of you already have some t-shirts and whatnot. Be looking forward to some more. But as far as what the money will go to, it'll probably go majority towards the software that we use. So, for example, the hosting for the website. If we end up using Jira or whatnot. Right now, we're only using like a password keeper for the oneleif passwords, as well as the hosting for the website. Okay, so direction channel. We have we want to rekindle the algorithm / kata channel, and this stream is kind of going to be geared towards that. So, for those of you that don't know, a kata is Japanese for a practice exercise. Actually, I wonder if we can get a literal translation here. A system of individual training exercises for practitioners of karate and other martial arts. Well, it's been generalized to other things. In this case, a kata is a practice exercise in coding. We will get to a kata later, where we're going to do a little practice exercise together, a little coding exercise. And what we did with the katas beforehand is we would post an algorithm or a kata for you to solve, and if you posted the right solution, we would give you XP or points in the oneleif Discord. And it's kind of just to show off, like you can, like if I go to the random channel, you can do T exclamation point profile, I believe, and it'll show you your XP, your level, and all that jazz. So right now, the way you get XP is just every message you do gives you a couple XP. I don't remember how much. And then we can award you XP based on completing katas and whatnot. So it's kind of a nice little bragging rights. Back to direction channel. My English is perfect. We do still need to update channel names, descriptions, and explanations and rules, because we have moved channels a lot, but holidays have kind of had us on edge. We haven't updated the Oops, sorry, hiccup. We haven't updated the Discord since then. Let's go look at what suggestions we have. Oh man, I got the hiccups. So, Arek, I hope I'm pronouncing that right, suggested that we add some preliminary information to active projects. Good lord. Such as the description and purpose, the repository or repositories, what tech stack it's using, and a link to the issues. Typically, that'll be on GitHub in oneleif. So look forward to us having some reference to those. I'm hoping we can add it to the oneleif website, so that way we have a central place for you to track all these things. I am sorry if you guys can hear these hiccups. I got a bad. Okay, next is the active project stand-up. So for those of you who don't know, active projects are projects that oneleif will help either you manage or we help ourselves manage. So for example, if you scroll down, good lord, if you scroll down, if you scroll down in the Discord here, you can see we have 4 channels for active projects. The first channel we have, good lord, the first channel we have here is the oneleif website. If you go to, I think I still have the website pulled up here. Okay, I haven't updated the name server yet. I believe you can still go to, I guess I don't have it on here. It's like oneleif.vapor.cloud or something along those lines. I got to update the host name. But the oneleif website is going to be the central place where you go to find posts on resources that people find or things that they're doing. It'll be where you go to find members, look at their GitHubs. It should be a central place that we can all meet up, and then Discord is where we communicate with each other. The other active project we have is managed by. Okay, so I manage oneleif website, but it's open for anybody to work on. It's written in Vapor, is the web framework, but it's written, the language that it's written in is Swift. Then we have Swift UI Kit, which is managed by Zach. It is a Swift. It is a Swift implementation of the Swift UI package written in UI Kit. So it allows you to basically make all of your UI code really quickly, really simply, really clean. So if you have any interest in joining any of the projects as I'm going on, feel free to message in those channels and get some more info until we have the oneleif website up where you can see the central place of information and get some more info on it. OL Go, or oneleif Go, is the oneleif mobile app. So this is going to be the iOS side of things. So as the oneleif website's being developed, the oneleif mobile app on iOS is being developed. We have a project created for the oneleif Android app, but we don't have a leader for that. So if that sounds like something you're interested in, feel free to message us. The last project is the Bunny Hop project. This is a game that I'm working on. It's a 3D platformer. It has portals. In the future, it'll probably end up being a multiplayer shooter, but for now, we kept it single player and nice and easy. Okay, so next we're going to go look at the streaming channel. See if anybody has anything that they'd like us to stream about. So some of the topics that we have up here now are clean code, so talking about how to make your code functional and readable. Solving a kata or solving a practice exercise. In the future, we're going to do polls to choose the language. This week, we're going to do C# because it's something I'm familiar with, and we can get through it quickly. And it's similar to Java, so it should be pretty readable. We'd like to have a tutorial on how to fork and make a PR and then update the board. For those of you who don't know what that means, I wrote a little guide in GitHub. Hold on, let me pull up the right window. So if you go to the oneleif website GitHub page, we have a little wiki here. And in here, we have a how to contribute page, and this will walk you through what open source is, how you get started, forking, all that jazz. So if you're interested in getting into open source, you don't know how it works, find this page. We'll have to get some better linking up. I believe there's a link to the wiki down at the bottom of the README. Yeah. To get started working, go here. Okay. So next we have channel updates. I don't know what I meant by that, to be quite honest with you. Scroll through the rest of these. We were talking about some CSS practices. So I went ahead and added the default stream topics and pinned it. For those of you who don't know how pins work, if you go up to the little pin up at the top, there'll be messages that are pinned to the channel that you can easily click on jump, and it'll jump you to that message. Since I'll show you if I'm not looked at it, it'll jump you to that message. Okay, so for proposals, we don't have any updated proposals. If you have a project that you'd either like us to help you work on, need us to help you manage, go look in the proposals channel. You can see some formatted proposals. You can see my proposal for Bunny Hop. Basically, what this means is oneleif will help you run your project, will help you get your board up and running, so that way you can have tickets. Will help you get your wiki started, so that way people know what their what the project is about and whatnot. And then this will be where people will talk. Once you submit your proposal, we approve it. It'll probably get approved. Our approval basically just means we need to add the channel for you. So once your project is approved, you get an active project channel, and now people can chit chat about your project. Last but not least, one sec. Man, these hiccups are killing me. All right. So we have this nice little resources channel. This is where we post cool resources that we find that are useful for you to learn from. So resources that have been updated since the last stream. I believe the last stream was on like 12/17 or something along those lines. Net data is awesome. It allows you to get all sorts of networking statistics on your Linux server. Ping, response times, disk writing, all that jazz. Awesome tool. If you run any sort of Linux server, it's great for you to check out. This one is for Unity. Unity is a game development engine. This allows you to put a browser in your game. Cosmin posted a nice little podcast here for learning about tech. Oh my goodness. If you guys haven't seen this yet, JSmold posted this. It's a little collection of 3D JavaScript websites. Let's go look. I think this is the one that I liked. So these are all just awesome 3D little projects. Oh, apologies about the audio. But yeah, it's cool to see some 3D stuff done in JavaScript. Typically, game engines are written in C++ low level stuff. So it's cool to see some web front end 3D stuff. I highly recommend checking that out. If nothing else, then to get some inspiration. The latest thing posted is about Circle CI. Circle CI is a continuous integration platform. Allows you to push your code up, and then it builds it, runs all your tests, all that jazz. So this is a nice little playlist, a little tutorial series teaching you how that works with Node and JavaScript. Also, if you guys haven't checked him out, the Coding Train is an awesome producer of material. He teaches you all sorts of cool things. Okay, well, we're progressing pretty fast. We're on to the last topic already. Let's solve a kata. So my favorite place to go for katas is CodeWars. And CodeWars is a nice little website that has all sorts of things on it. Basically, it allows you to get in like a clan or a group, and it allows you to track progress of other people. You can see Zach has a ton of honor. He's completed a lot of challenges here. We highly recommend this if you're trying to either get into programming or you're trying to hone your skills for an interview or whatnot. So yeah, we're going to go ahead and solve a kata together. So the kata that I've chosen today is about isograms. I'll zoom in here and let you guys read it for a second before I move on. So an isogram it's basically like it's examining strings here, right? So basically what we're looking for is to check if a string has any repeated letters, consecutive or non-consecutive. So we can have down here you can see some examples. So we can see dermatoglyphics is true because there's no repeating characters, right? Like there's only one D, right? And we're not we are not case sensitive. Case sensitive? Yeah, we are not case sensitive because we can have a capital D and we cannot have a lowercase d after that. So you can see ABA would be false because the letter A is repeated. And moose with a capital O is false because we're ignoring case, right? So a lowercase o and a capital O are equivalent here. So in CodeWars, they give you this nice little terminal that you can write your code in, right? So in my case, I'm choosing the language C# because it's something I'm familiar with. It's something we can blast through really quick. In the future, we'll have polls to suggest the language that we can use. If you're interested in JavaScript, for example, we can do that. So if I were to go to the katas page here, you can choose the difficulty, 8 being the lowest, 1 being the highest, and then you can choose your interested language. So they even have smaller languages like R, for example. Some of them are in beta, but the majority of them work pretty well. So I chose a C# based language, or for the language basis, and then I chose something relatively easy. I believe we're at a 7Q. I don't know if it I don't know if it shows it to you on the page itself. I believe this one is a 7, which is like, oh, there it is right there. So this is like the second least difficult language or task that you can do. And there's so like in 7Q there could be 100 different katas for you to solve. So let's go ahead and run you through the interface. So we have the instructions, and then we have the output, right? So how does it get the output, right? So you write your code, and then it runs these tests down here, right? I can make this bigger. Awesome. So it's using in-unit for unit tests. It's just using the basic system libraries. And now we have a test fixture, which is basically like a harness for you to be able to write your tests. They have a basic test class, and now they're going to enumerate over all the following tests. It's going to pass in dermatoglyphics for the test case data. And if it returns true, which it should, right? Because this doesn't have any repeating letters, then this test is going to pass. And then, moose shouldn't pass because there's 2 O's. So it should return false. If it returns false, this test will pass. Right? So let's go ahead and just hit uh, run. Am I missing the run button? Haha, run, attempt. Okay, so you can see, not all code pass return a value. Well, we're not returning anything. So let's just try this. Return false. Okay, so you can see which tests pass and which tests fail. So moose, for example, is green. It passes because it should return false because moose is not an isogram, right? So we've passed, I don't know, half the tests-ish. So you can see the basic tests are the ones that we can see down here in the sample. And then they run some more tests or some more complicated ones to make sure that you are indeed passing and you can't just cheat it like we are here. So rather than writing it in this little terminal here, I'd actually prefer to write it in Visual Studio because it has autocomplete, it has coloring I like, it auto tabs, all that jazz. So we're going to go ahead and create a little Visual Studio project here. I'm using Visual Studio 2019 Community Edition, or the free edition. Visual Studio 2017 will work fine as well. So we're going to go ahead and create a new project. We're going to create a .NET Core console app. And we'll just call it oneleif kata 1 to 2020. And we'll go ahead and put that in my documents coding folder. We'll go ahead and hit create. So this is just going to be a simple console application that will run in the console. I like doing all of the katas in a little console application because I can debug easy. I can see what things are when they're running. It allows me to debug, and that's not something that the codewords interface gives you. It'll only give you feedback as though it were a compiler and the test cases. You know what? I am curious. Since they're using system, we should be able to console.writeLine and just see if it even allows you to print things. It does not appear so. Oh, log X. Cool. So you can actually write your stuff in here and do print statements basically for your debugging, but I still prefer Visual Studio. It's something I'm familiar with. It's kind of the golden standard for working in C#. Okay, so in order to not hop back and forth between the instructions and whatnot, let's go ahead and copy them over and just put them in a comment up top. Okay, so now we have our instructions in here. Now we don't have to hop back and forth. Now we can start writing. So by default, it automatically creates a namespace, which is basically like a package or basically a grouped set of code. We don't really necessarily have to worry about this since we're just in a console application. Same with the class here. The class that we're making is just called program. We could create other classes and implement them in here, but we're just going to keep it simple. We're just going to use basically the defaults that it gives us. And let's actually pull this out and move it up to the top to make it a little bit cleaner. Okay, so the main function is where our code is going to be ran. It is equivalent to the line 7 of this function. So basically, once we hit run on our program in the codewords interface, it would run this line as the first line of execution, whereas in Visual Studio, line 15 is our first line of execution. And let me go ahead and zoom in and make it easier for us to see here. Okay, so what do we want to do here? We want to check if any of the letters are duplicates, right? So what seems like the easiest way to check that? Well, to me, the brute force method would just be to loop over all the letters and say, have we seen this one before? No? Cool, we're good to go. If we have, we go ahead and break out and return false, right? Okay, so let's go ahead and take in, we could take it in as an argument to the console application, but in this case, I think we can just kind of cheat around that and have our, we can just create a string called test1 and set it equal to moose. So we know this one should fail. Oh, so we'll call this a failing test. And then we'll create another string called passing test. And we'll just put in the letter, I don't know, ASDFGH. Okay, so now we have a, if I can remember the equal sign. So now we have a passing and a failing test. So if we were to run our program and pass in failing test, it should spit out, let's say, failed. Ooh. Failed, for example, right? So rather than writing all of this in the main function, I like to keep my code clean. Let's break out of this and write another function called isIsogram. So it has to be static. If you aren't familiar with C# and statically typed languages, it might be object-oriented, not a statically typed language thing. If a function is static and you want to call another function from it, it also has to be static. I'm going to kind of gloss over this. This isn't something that you necessarily have to worry about. So we want to return a Boolean, whether or not this is an isogram, right? And then we want to pass in the string, and we'll call it the string to test. Okay, so right off the bat, if we hover over this, it's a red squiggly line that usually means an error, and it says the function is isogram. Not all code paths return a value. Well, it's expecting a Boolean as a return type, and we're not returning anything. So to get rid of that error, we can just return false for now. Boom, we're good. And we have these dot dots, and usually that means it's kind of like a syntax error. And if you hover over it, you can see it says naming rule violation. The beginning of functions must begin with uppercase. So in most languages, they want like camel cased. Camel meaning it goes low and then high and then low, kind of like the hump of a camel's back. But in this case, we want a capital for the first letter and then a capital for the first letter of the second word. That's just C# basic syntax. And now it's freaking out because it's unused, but we'll get there. So if we pass in, let's go ahead and write if is isogram. Oh, my bad. If is isogram failing test. If it is an isogram, then we want to print out we are an isogram. Otherwise, I'm lazy, so I copy paste. We are not an isogram, right? So if this works as expected, right? If we're an isogram, which moose is not, so we don't get in here, we should print out we are not an isogram. Since this returns false, it should go ahead and follow this line of execution. So let's go ahead and test just to make sure. Let's just do a sanity check and make sure that we're not going crazy. So to run in Visual Studio, you just go ahead and hit this giant green run button up here, and it will open up a console. And it says, boom, we're not an isogram. Cool. And then it has all this extra stuff that you don't need to care about. So now that we are this far, so for those of you who don't know, in Visual Studio, if you don't like print out something, the console will automatically close. So that's why we're printing out something, not like returning true or false. Okay, so our sanity check has passed. We are doing as expected. However, we're not actually checking whether or not it's an isogram. If we put in passing test, it wouldn't go to this line of execution because, well, it's just going to return false no matter what. So let's go ahead and actually solve this in the most simplest way possible, right? So let's say we have the simplest way I can think of to do this is to loop through each character in our string to test. Ooh, we got to add a for each. So what this does is for each character, so for each letter in our string. So if we're doing the word moose, the first line of the first time we run through the for each loop, it would just have the letter M. So for each one, let's check if we've seen it before, right? So let's store off what we've seen before, right? So let's create just a list of characters. Characters we have seen. And we'll just make it a new list of characters. And now it's going to yell at us because we don't have, C# doesn't natively know what a list is. So let's go to show potential fixes. Ooh, it's freaking out. And it says, oh, let's just import list, right? So now it's not going to freak out. So now we have this empty list. So for each of the characters that we have, we need to add it to this characters we have seen. So let's do characters we have seen dot add, and let's add the character that we're currently at. Right? So this will keep track of all the characters that we've seen, right? So let's check at the beginning of this for loop to see if that character is in there yet, right? So we say if characters we have seen dot contains. So if it contains the character that we're currently on, we immediately return false, right? If we've seen this character before, then obviously this is not an isogram. If we get all the way to the end of this, like if we've gone through all the letters, then we should return true, right? So let's do this step by step with the word moose. So the first character that we get is the letter M. The characters we have seen is empty, right? So does the characters we have seen contain the character we're currently looking at? No, the list is empty, right? Well, let's add it to that list then, right? So now characters we have seen contains the letter M. So we go to O. Have we seen that character yet? No, we have not. So we keep going. Now we add that character. So now our list contains M and O. Now we go through the second O, and obviously we have seen that, so we're going to immediately return false. Cool, this makes sense, right? Let's go ahead and see if this passes, right? So let's run failing test. I don't want to copy paste this because this is going to get gigantic. We'll do it for simplicity's sake for now. So we'll do failing test and then passing test. And then we'll say, we'll keep it simple for now. We could like add it into the printing out, so we could say blank is an isogram. Okay. So it says moose is not an isogram, obviously. Cool, that makes sense. And then ASDFGH is an isogram. Perfect, this makes sense. All right, so let's go copy our code. So we're gonna have to shadily copy our code to see if it works correctly, right? So really all we're gonna need is the actual is isogram function, because they already did the rest of it for us, right? So if we go ahead and copy our code in here, and we hit attempt, obviously the formatting doesn't work as expected. All right, so if we go ahead and hit run, it's going to say, oh, we don't know what list is. Oh, we imported that, right? So let's go grab the import that we grabbed, or that we fixed with earlier, and paste it up in here, and let's try running it again. The name string2 test does not exist. What did I do wrong? It didn't copy string to test correctly. So let's go ahead and paste string there. because they named our variable for us. Okay, so we can see some things failed. So if we look through dermatoglyphics that passed, it should. So as we go down, we can see, oh, moose fails. Wait, why is that? Sorry, M-O capital O fails. Well, if we are looping through, contains, if you hover over it, it determines whether an element is in the list. So what it's going to do is it's going to check this list for if we've seen capital O, and all we have in there right now is a lowercase o. Crap, what do we do? Well, we can either implement our own little contains method to not check for case, or when we add it to the list, we can just turn it into lowercase. So we can do this is not something I've done before in C#. To lower. Haha. The char class has a to lower function built in. So we can go ahead and turn our character into a lowercase character and add it in when it's lowercase. All right, let's see if this guy works. I'm just going to copy this line because we have the rest of it already, and we'll paste it in. Ah, okay. So we we added it lowercase, right? But we're still checking if it's uppercase. So let's turn it into lowercase at the beginning of the function, right? So we can say char character to check is going to be equal to the current character that looking to that's in lower, right? So now we're going to see if we have contained that lowercase character, and then if we have, let's add it. So let's try this now. Boom, all of our tests pass. And it will show you how long it took. It took 2.5 seconds, or 2500 milliseconds, right? Well, 2.5 seconds to run some very simple string tests. Well, if we're running this on a really big server, like let's say we're Facebook, for example, that doesn't seem fast enough to me, right? That seems like if somebody wants to search for whether or not something is an isogram on Facebook, and we have a million users doing it, well, that's just not going to scale up very well. So let's see if we can figure out a quicker way to do this. And the thing that comes to mind is to use some built-in functions to C#. And this is going to get a little hairy because you haven't seen this library yet, but a lot of higher level languages, C#, Swift, Kotlin, will have higher order functions, or those that can do easy things for you. So like doing for each could be done in a much more simpler syntax, and it could handle some of the heavy lifting for you. So let's see if their library is any faster, right? So the library in C# is called link, L-I-N-Q. So let's go ahead and import link up here. And then let's transform our function that we're using here into link code, right? So the way that we would do that is we would say we're going to go ahead and our function here is going to return. So the little arrow function here says we're going to return something. And what we're going to return is the string to test, and then we're going to turn it into all lowercase off the bat. And then we're going to say where, and what do we want to say? Where we have a letter. So far we're saying we're grabbing the string and we're turning it into lower, and then we're saying filter. So the where function filters a sequence, right? And our sequence here is our string. Our string is a sequence of characters, right? So we're filtering where the character where the thing that we're filtering through is a letter, right? And then we're going to group it. And you're gonna have to bear with me, this is gonna look a little scary here. We're gonna group it by count, right? So we're gonna group, what am I doing wrong here? Capital C. Let's go ahead and break these out into their own lines. This the nice part about C# and other higher level languages is that you can move things to different lines, so that way it's a little bit easier to see, right? And it's bad because char does not contain a definition for count. Oh, I'm doing this wrong. My bad. we're going to go O to O. And bear with me, this is going to look really ugly for a second. We're going to grab all of them where O goes to O dot. There's our count function. And we want the count equal to 1. Okay, so let's go back through this. We take our string to test. We turn it all to lowercase, so that way we don't have the problem that we had with moose, right? It'll turn it all to lowercase, so that way when we loop through it, we don't have to modify it. So that should turn that moose into all lowercase moose. And then we want to group it, or we want to filter it where they are letters, right? So it indicates whether the character that we're looking at is a Unicode letter. Unicode is just a format of characters. And then we group it. So we group O's into O's, and we do this so that we can use the all function. So we determine whether all of the things in each of the groups conform to this function, right? And we're saying, do all of the groups have a count of 1? Meaning, do all of our grouped letters, so if we group O's together, is there only one of them? Well, no, in the moose case, right? But if we removed one and called it Mo's, it would be one, right? Because there'd be a group for M, a group for O, a group for S, and a group for E. So let's go ahead and copy this guy over to the kata, and let's just see if the integrated or the built-in link functionality is quicker than the way we were doing it. Like let's see if their library somehow is faster than ours. And don't forget, we have to import a link up here. Is that system.link? Yeah. Link. Boop. And we have to remember to use our nice, pretty little arrow syntax. In some languages, if you want to be able to look it up, I believe it's called lambda syntax. Lambda. 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 Yeah, cool. Look up lambda syntax. A lot of the updated languages have it. So let's go ahead and run this and see if it works. The name. Oh, gotta remember to rewrite our string name. We should have done that in the first place. I should have done that in the first place. Okay, all of them pass, and it runs in 2.4 milliseconds. So we shaved off 100 milliseconds by using a built-in function. And once you understand how lambdas work, this to me is cleaner, because I can see each individual function that's being called on the data, right? I can intuitively grasp what's going on here. I'm turning it into lower, I'm grouping them by letters, and then I'm checking if the count's 1. Rather than doing this for loop and having all these extra brackets and whatnot. So this is my solution. So what you can do once you're done is you can submit it as your final solution down here. Wait for it to go. Now we can go look at best practice solutions. Oh, we can see they go 2 lower. They grab them by distinct, meaning if if each one of them is if each of those letters is distinct and the count is equal to the string.length. So if we have moose, the string.length is 4. Well, if we cut them out by distinct, there's only going to be okay, let me pull up something here to visualize for you guys. Let's go ahead and delete all this. So if we have moose and we move them into to distinct, if we filter them by distinct, we're going to have mo's left, right? So what it's checking for is if the length of what's distinct is left. I said that awful. If the length of the thing after you do distinct is equal to the length of the string, then we know we didn't filter any letters out, right? So you can see this is like the most upvoted solution. To me, that is way cleaner than what I did. That's awesome. So what you guys can do in the future is look at once you have found a solution, you can look at the best practice solutions that are out there, and that's why we highly recommend CodeWars as your platform. I need to go check the stream and see if anybody has said any messages. Otherwise, I have talked very quickly and probably ended the stream in, what is that, 40 minutes? Yeah, 40 minutes. Well, guys, if I went over anything that you didn't understand here, feel free to send us a message. If you're not in the One Leaf Discord already, go to just type in One Leaf in Google. You should be able to find us. Actually, let's go see. I'm intrigued. Google auto completing for me. One Leaf. Aha! You can find our our old website, and it should have a link to Discord right here, and you can click on that to join us. The oneleaf.com website will be up hopefully momentarily, but until then, that's what we got publicly available. So if nobody has any questions, I'm going to go ahead and end the stream there. I thank you guys for watching, and have a good night.